to be the output of the following flowchart when the input number is 4. Okay, let's see what happens. These are the variables inside the memory. This is your computer screen. Start, read, M. Okay, start. We are reading reading number, which is a variable num. So as we said, it is 4. Okay, then we are initializing those two things, those two variables. Result equals to 0 and count equals to num. So num is 4, we've been given to it, and the result is going to be 0, and the count is going to be 4. Why? Because we've said count equals to num. The value of num is going to be assigned to the count. Then the program comes here, print count. How much is count? Count is 4, so the count is equals 4, and it's going to be appeared here. And then it comes to this point, count greater than 0, 4 greater than 0, yes, it comes here. What happens? Result equals to result plus count. This is important. This one the new result, this one the old result. How much was the old result? 0. So the new result is going to be 0 plus count, which is 4, and count is going to be count minus 1, so the count is going to be 3. It decreases itself by 1. This is the new count, this is the old count. The old count was 4, minus 1 is going to be 3. Okay, and let's see what happens. So the result is going to be 4, the count is going to be 3, and the program comes back here and it says print count again. How much is count now? It's 3, so count equals to 3, and the program comes here, 3 greater than 0, yes, so yes, so it comes back here, result equals to result plus count. So this is the new result, this one is the old one. So the old result is 4 plus the count, which is 3, is going to be 7, and the count is going to be decreased by 1, it's gonna be 2, so it's 7, 2, and this happens, this repeatedly occurs until the count is going to be 0. Okay, so count is 1, yeah, 1 is greater than 0, it comes back here, this happens up to here. So we are printing count, which is 0. So 0 greater than 0, no, the program comes here, it prints the result. How much is the result? Here is 10, so it prints 10. Result is 10, and the program stops. And this is an in-class exercise. You need to do it by yourself. What will be the output of the following flowchart with the following input? If the book is green, 350, curtain red, 500, so it's going to be the output. You need to do it by yourself. This is another one, this is another one. So we have another type of the selection structure, which is called nested if. What do you mean by nested if? If we have an if inside another if. Now here, if this condition is true, come to this statement. The whole things inside this if is a statement. So when this condition is true, comes to this statement, there is another if inside this if, which is called a nested if. If this one is true, then this statement executes, then end if. Here is the example in the flowchart. So nested if with if. Okay, it comes here. If it's false, it comes to this point. If it's true, it comes to this point. Now we have another if. As we said, this shape is if inside the flowchart. So if it is false, again it comes back to the end point. But if it's true, then this statement takes place. So this if condition, this statement can be considered as a statement for this if condition. Yeah, like this. Here we have if else if, and we have a nested if using if else if. So we've got if this condition is true, this takes place, else this one takes place, this one is executed, and this one the end of the if. But if this one is true, it comes to this statement, and this statement is another if with another statement. So both of them can be considered as a statement. So we can play with the if and else as much as we want. Now we have a complex if else if statement. Okay, we are starting with something here comes, there is a condition. If it is false, it comes to this statement and it comes to the end. But if it is true, this statement occurs. It comes to this one. There is another condition here. Look, we have a condition inside this condition. If it is true, this statement occurs and it comes to the end. If it is false, it directly comes to the end. Okay, all of these together can be considered as one statement. Okay, now we have a pseudocode for the nested if else condition. Now for example, we have a if condition. If this one is true, do this one. Else, if this one is true, do this one. Else, if this one is true, do this one. Else, this one is going to take place. And the end. If look, we've got so many different conditions for something here. For example, the first one is this one, and then it comes to this one. If it's not true, then this one occurs. If it's not true, then this one occurs. Then it goes to the end of the if condition, like here in the flowchart. So we come into the condition. If it is true, this one takes place and it comes to the end. If it's false, it comes to this condition. If it is true, this one takes place. If it is false, it comes to this condition. If it is true, this one takes place. If it is false, this one takes place. Look, we can have as much as if and else inside our algorithm or inside our program. We can have as much as conditions inside every single program. Okay, this one is an in-class exercise. So we are supposed to associate noise loudness measured in decibel with the effect of the noise. The following table shows the relationship between the noise level and the human perception of noise. Draw the flowchart of it. So if, look, I'm saying if the loudness in decibel is 50 or lower, that means it's quiet. If it is between 51 and 70, that is intrusive. If it is between 71, 90, annoying, 91 to 110 is very annoying, above 110 is uncomfortable. So you are supposed to draw a flowchart for this one. For example, it is another one that the flowchart is given, so you are writing a pseudocode for this one, and you are supposed to write a flowchart for and a pseudocode for this exercise. So you are supposed to do it inside the classroom. If the student gets the if the grade point between 0 and 99, you are getting fail. If between 1 up to 1.99 on probation, 2 and this value average, dense least and highest honor. So you are supposed to write a flowchart and the pseudocode in order to implement this